In this interactive simulation, we have a mass that's attached to a spring, and this simulation is going to allow us to see the relationship between the wave amplitude and the period of the motion. So what we can do with this is we can pull the mass down slightly, and we're going to get a plot of what the position of this mass is as a function of time over on the right. And it will eventually stop when it reaches sort of an end time. Okay, so when the system stops, we see that the amplitude of the motion is basically the maximum displacement from equilibrium. So how far I pulled it down to start with here is the amplitude, and it oscillates about its equilibrium position, which is its starting position. And so here we have our amplitude of the motion, and then we also have the period. The period is the time it takes this mass to complete one cycle, or to go from here all the way up, all the way back down to the lowest position and back again. So here is our period of the motion, and in this case our period is 2 seconds. Let's see what happens when I displace the mass on the spring to a larger amount. So we notice that the amplitude has increased because we've pulled it down and started it at a larger position, and that mass is going to oscillate about that displacement through the equilibrium position. So it's going to bounce up and down, and so my amplitude has increased, and we notice that the period is still 2 seconds. So the period of the motion stayed the same, and that tells us that the amplitude of the motion and the period of the motion are independent of one another. If we were to be given the distance between the crest of a wave, and the crest is the top part of the wave, and the trough is the lower part of the wave, if we were to be given the distance between the crest and the trough, we could figure out what the amplitude of the motion is by taking half of the distance between the crest and the trough, because the amplitude is measured from that equilibrium position, and the mass oscillates about that equilibrium position, the same distance above and below.